I've always had a huge interest in space architecture, not only because of a desire of exploration planted based on the influence of modern media industry, movies, and video games, but also because of the ongoing pandemic triggers me to reconsidering the relationship between Earth and human being. The current stage of Earth is overloaded by human desire, and we're coded to respond to urgency once it's actually violated one's personal interest or benefits. Hence, I like the sentence mentioned by NASA's research where life continuing on Earth is not guaranteed. Therefore, I started to look into human relocation project in the discipline of architecture. Many architecture firms express their interest in Mars colonization through imaginary drawings and renderings. But why Mars? Daily schedule always have a huge impact on our psychological and physical health. The length of a Martian day is especially close to that of Earth, within 24 hours, 39 minutes, and 35 seconds, that provides a similar 24 hours of cycle for human body regulation. Moreover, comparing to Earth, Mars has a similar stage of infancy. In NASA's report, they confirmed the existence of polar caps, which could be the source of water in the future. Meanwhile, the investigation on electrical effects on Mars could be source of continuous and episodic energy. However, with increased amount of advanced information provided by NASA, more critical problems of human habitation on Mars appeal and need further address in the architectural design. Hence, a closer evaluation of previous projects is essential. With the research, I conclude 4 different design stages of Martian architecture. Since NASA's mission plans one trip to Mars is approximately 180 to 210 days, hence the early stage of living condition was about the trip and transportation. When people arrived on Mars, it entered the second stage of settlement, where construction is mainly with material that was originally brought onto the trip. After that, the third stage happens when the exploration team develop a method of utilizing local material to master a new building technique. Finally, the last stage is development a deployable mass production buildings into clusters of architecture with larger programs and functions. With such conclusion, I start to divide the research projects into clusters, and I realized that there is a disconnection from the first 2 stages to the last 2 stages of design. There's a lack of understanding on the first 200 days of the trip. What kind of living condition would that be expected, and how would the design shifts once entering to the second stage of landing? The current Martian architecture design is always viewed from a distance angle and with a fancy rendering, which comes to the problem of lacking understanding of a first-hand feeling and a close-up perspective of the entire cycle of the trip. Therefore, in my thesis, I would like to fill in the gap between the stages by studying on behalf of the first 2 phases of the trip. According to the company SpaceX, cost is one of the biggest constraints on the pushing forward's progress of relocating in space. As a hypothesis, if the body of the landing rocket could be reusable, the cost barriers to human Mars exploration would be significantly reduced. Therefore, another set of questions should be asked during the design. Can we reuse the parts from the rocket carriage? What to build with the spaceship? And could it be repurposed after landing? To conclude, this thesis will consider the entire trip as a cycle of design, with a less concentration on a bigger image shift into a closer study of behavior and spatial interaction, meanwhile addressing the idea of using design to connect stage 1 and stage 2 of the landing mission. Therefore, in the first phase of design, I would like to start by generating a singular living cell, one small unit that can close considering on living and social behavior during the trip. The experience of zero gravity will be simulated through Blender physics engine. The second phase of design will be experimenting with 1-to-1 scale model, closer look into the actual hands-on feeling of the space and choreography. Furthermore, arranging the cell into parts of the spaceship and design the transition of form to function from a living cell into potential deployable architectural elements after the landing.